Hello everyone, welcome to class. Sorry about all the confusion yesterday, and I know that this is pretty late. I was really hoping that the recording I made would show up today, and it hasn't, so I just figured this is probably the safer way to do it. So we're looking at week 8. Hopefully you guys had a great spring break. Make sure when you're submitting those mystery numbers that you submit them for week 8. If we're taking a look at our schedule this week, today, if we're talking about it in terms of Monday, we're going to be looking at solving perfect square equations. So we'll actually do Monday and Tuesday work. Tomorrow and Wednesday, you do not have an assignment. And then Thursday's class, we'll talk about completing the square. It's really kind of just two content areas that we'll be talking about this week. So our goals today, we're going to be looking at solving quadratic equations involving perfect squares. And there's 3 different ways we can do this. So we'll take a look at those 3 different ways and we'll practice all of them. So the first one, it's going to have an equation, and the best way to solve this equation is to isolate that variable, meaning getting x all by itself and then solving from there. The reason we have this positive and negative sign here is because whenever we take the square root of something, we can always have a positive or a negative answer. So if I were to take the square root of 4, I could get that to be a positive 2, or I could get it to be a negative 2, so we just write it as a positive or negative 2. This would be showing us that we can include both of those answers because negative 2 squared is positive 4, and positive 2 squared is also positive 4. Okay, so let's take a look at an example of this type. So the first thing that we have to do if we're looking at 9y squared equals 4 is we want to get that y all by itself. Well, right now there's 9 being multiplied as well as it's being squared. So the first thing we want to do is get rid of that 9. Because it's being multiplied, we're going to undo it by doing division. If I do it to the left, I have to do it to the right. So again, this is kind of just solving an equation. So I'm left with y squared equals 4/9. So now I have that y all by itself, but I have to take the square root of it in order to get the y solely by itself. Remember when we're square rooting and we have a fraction, what it actually turns into is the square root of 4 over the square root of 9. I simplify that and I get 2/3. And our very last step is to take the positive or negative answer from there. So my answer would be y could equal a positive or negative 2/3. If we're looking at the next one, we have a few things going on. We have multiplication by 2 as well as addition by 1. So we're just going to start by solving this equation step by step. So I'm going to subtract 1 from both sides. So I'm left with 2t squared equals 18. I'm going to divide that 2. So I get t squared equals 9. Take the square root of both of them. Again, we're just trying to get that variable all by itself. So I get t equals, use that symbol, positive or negative, 3. So again, the first way is just solving these equations, just like we've seen in equations step by step. The last way, again, just continue on the same way. So adding 7 to both sides. So I get 25x squared equals 16. Divide by 25. And again, you can see that we're going to be getting a fraction here. So I take the square root of that x squared. If I change that fraction so that I look at it individually, square root of 16 is 4, square root of 25 is 5. Take that positive or negative symbol, and then x would equal a positive or negative 4/5. So that's option 1, just solving an equation like we've done in the past. The next type is where we actually want to take the square root first. So you will see in these types of examples that you probably have a parenthesis and the parenthesis is squared. So when we can square root it, we are actually eliminating that parenthesis. This only works when you have a perfect square on the right-hand side. And I'll show you an example in just a second. So you take the square root first and then you solve. So kind of the opposite of what we did in the last set. We solved and then took the square root last. Again, that positive or negative symbol is going to come up. So if we look at an example, you can see that I have 9, 36, 16, and 25. All of those end up being a perfect square, meaning when I take the square root, I get a whole number, and that's why this will work. You can also see that all of this, the pattern is that there's a parenthesis being squared. So when I take the square root of both sides, it's going to work out perfectly. And that's the idea when we work with these perfect square equations, that they only work so nice and neatly because they are perfect squares. So I'm going to erase some of this here so we have some room to work, and we'll look at that first equation. All right, in this type, our first step is to take the square root right away. What that's going to do on the left side with the parentheses is actually just get rid of the parentheses. It's saying we're getting rid of that squared term so that all we're left with is whatever was inside the parenthesis. On the right, then, we are left with a 3. From there, we have to make sure that we take that positive or negative 3. So what I actually have, oops, lost my symbol, is I could have a minus 2 equals a positive 3, or I have a minus 2 equals a negative 3. All of these will have two answers. In the last type, they're going to have the same answer, just one's positive, one's negative. When you solve for this type, you're going to find that you actually get two different numbers, so make sure you're aware of that. So now I solve for my variable. So I could get a could equal 5, or a could equal negative 3 plus 2, a will equal negative 1. So you could see that before we just had the positive or negative answer. Because we're in a different step and we took that square root first, our solutions are going to end up being two different numbers. So make sure that you're aware in this type that we have two solutions. Okay, let's do another one. So I'm going to take, I'm going to take that square root first. So if I take the square root of the left, I'm just left with y minus 3. And if I take the square root of 36, I'm left with a positive 6. And I'm also left with a negative 6. So right off the bat, I'm going to write those two equations so we can see we have a positive and negative 6. Then I just solve. So y can equal 9, or y could equal negative 3. Again, because we're changing the order of when we take that square root, that's ultimately what happens here. We'll get two separate answers. Okay, I'm going to erase the top right here, give us some room to work, and we're going to do the very bottom equation. So the 5x plus 4 squared equals 25. So I'm going to take the square root of both sides. So I get 5x plus 4 equals a positive 5. Square root of 25 is going to give us a positive or negative 5. So then I also have the 5x plus 4 equals a negative 5. Now we have to solve our variable just like solving an equation that we've looked at in the past. So subtract 4 from both sides. So I'm left with 5x equals 1 and 5x equals negative 9. So you can see now we're going to get some fractions, and that's just fine. So we'll divide by 5. So x could equal 1/5. If I divide by 5 here, or x could equal negative 9/5. And you could put that as a mixed number if you choose. Again, leaving it as a fraction is completely okay. So far we've looked at two ways. The first one is just straight solving an equation that has that squared sign in it. And then we've looked at this way where we have to take that square root first in order to solve the equation. So kind of those are backwards. Those are opposites of each other. One was solve the equation first, then take the square root. This way was take the square root, then solve the equation. You can see that they're opposites. Now this last way is a little bit different than either of those two. Okay, so in this last way, the important thing to know is that we're actually going to factor. So we spent all of last unit practicing factoring. So these are perfect squares. Now when we factor a perfect square, it's actually going to end up looking very similar to this idea. where you have a parenthesis squared. Um, but then we're going to take the square root and solve. So it's very similar to the last idea, except we have to factor it first. So you can see there are points that are very similar, right? So we have all of our perfect squares on the right. However, on the left, we have trinomials. So first we have to get it in factored form, and then we can do it step by step like we just did. So let's take a look at the very top one there. So first of all, I want to find out what multiplies to 4 and adds to 4. In this case, my factors that multiply to 4 are 4 times 1 and 2 times 2. Well, 2 times 2 would get us to 4 if we added that. 2 plus 2 gets us to 4. So that tells us that I have x plus 2 squared equals 25. So you can see now it's exactly like that last type that we just looked at, where I take the square root of both sides. I get x plus 2. The square root of 25 is a positive 5 and a negative 5. And then I'd solve just like we did. So subtract the 2. So x could equal 3. Subtract the 2. Oops, sorry. And then x could equal negative 7. So very similar, we just have to look at that factoring first. So on the next two examples, I'm not going to solve the equation. I'm just going to look at how do we factor it. Okay, so I have what multiplies to 9 and adds to negative 6. Because we have that negative there, I'm going to start thinking about our negatives. So I could do negative 1 times negative 9. If I add those, though, negative 1 plus negative 9, that gets me negative 10. That doesn't work. So negative 3 times negative 3 gets me a positive 9, and negative 3 plus negative 3 gets me a negative 6. So that's our answer. So I'd have, oh, that's y. Sorry. So I'd have y minus 3, because we got that negative 3 there, and that would be squared equals 16. So that would be the factor, and then again, take that square root and solve, just like we did over here. If we're looking at the very bottom example with t, again, I'm going to have 2 negatives because this is a negative. So 6 times 6 gets me 36. 6 plus 6 will get me 12. So I'd have t minus 6 squared equals 9. I take the square root of both of those sides and then solve that equation. Okay, so just to review, we looked at the 3 different strategies that we can choose when we have an equation that just looks like a straight equation. I can't factor anything, and there's no parentheses that have the whole thing squared. That means I just want to get that variable all by itself and then solve with the square root. So the square root will come last. When I have one that looks like this, where I have a perfect square on the right and I have a parentheses on the left, that means I just want to take that square root and then solve for the variable. The last type is where we have that perfect square trinomial on the left and a perfect square on the right. So I'm going to factor the left side so that it can look like those parentheses and then take the square root. Okay, so just some reminders. Oh, we need some mystery numbers here too. Make sure you complete the checkpoint and the quiz. I have office hours tomorrow if you have questions. You have a Your Choice day on Wednesday, so there is no assignment that you have to do. And then, barring any horrible issues with technology again, I will see you all in class on Thursday. Thanks for hanging in there with me. Your mystery numbers today will be 0 and 19. Have a fantastic day, and I look forward to seeing you on Thursday.